Graphing the reciprocal of a quadratic function will be the same as graphing the reciprocal of a linear function. However, to find the exact location of the invariant points, you may want to set the f of x, or the original function, equal to plus or minus 1, and then solve for the x values. So let's take a look at an example. So given f of x equals to negative, and then in brackets x plus 6 all squared plus 4, we're going to write the reciprocal function, and then all we have to do is actually just write this as y equals, and then 1 over the function itself. So negative x plus 6 all squared, and then plus 4. So if you want to state and find the non-permissible values of x in the equation of the vertical asymptotes, which end up being the same value, then what we need to do is we need to set the denominator equal to 0, because remember that in a reciprocal, we can't divide by 0. So what we have is negative x plus 6 all squared plus 4 equals to 0, which is really setting the original function equal to 0. So we're going to move our 4 to the other side, so we get negative 4. Let's get rid of the negative sign on both sides. So we get 4. And then we're going to square root both sides. And then don't forget, whenever you square root, you're going to get the plus or minus. So we'll place it on the right. So we have x plus 6 equals plus or minus 2. So x equals negative 6 plus or minus 2. So solving for these different values, we get x is equal to negative 8 and negative 4. So therefore, these are our non-permissible values, but they also will make up our asymptotes. So our asymptotes will then have the equation x equals negative 8 and x equals negative 4, which means because they're x, it means that they're going to hit the x-axis. To get a better idea of what our graph looks like, let's also find our intercepts. So for our x-intercepts, because the graph is a reciprocal, and we know from before that the graph will not hit the x-axis, there actually won't be any x-intercepts. So for x-intercepts, there are none. So let's find our y-intercepts. So we get y equals, and we're going to plug in 0 in for x. So we have negative 0 plus 6 all squared plus 4. So solving this, we get 1 over negative 36 plus 4, which is negative 32. So we get 0 and negative 1 over 32. All right, so now let's graph. Now to graph the reciprocal, let's first graph our original, just like what we did with the line. So I'm going to recopy the equation down here so we can see it better. So y equals negative bracket x plus 6 all squared plus 4. And let's use a table of values. So we can see our vertex is negative 6 and 4, so we'll place that in the middle of our table. And then we'll pick two numbers on either side. So we have negative 7, negative 8, negative 5, and negative 4. So plugging this into our equation here, negative 5 we get 1, 1 squared, so negative 1 plus 4 is 3. And if we figure that out with negative 7, we'd also see that's 3. Plugging in negative 4, we get 2. 2 squared is 4. So negative 4 plus 4 is 0. Now, because I can see that it just hits 0, I want to find out what happens on the positive side. On the negative side as we go further away from the vertex. So let's also pick negative 3. And when I plug that in, I'm going to get 3 squared, which is negative 9, and then plus 4, which is negative 5. All right, so we always want to be able to extend past 0 because we don't want the graph just to stop at 0 and then we don't know what happens on the other side. All right, so let's graph our parabola first. So I'm going to pause here and you can try to do this on your own. All right, so I've graphed the parabola here. I was able to graph also negative 9 and negative 5 because remember that the parabola is reciprocal. So I just took the same point of negative 3, negative 5 and graphed it on the other side. All right, so now what we want to do is to now find our asymptotes. So remember that wherever the graph hits the x-axis, those become our asymptotes. So I'm going to draw some asymptotes right here. So one set at -8 and also at -4, which also corresponds to what we had when we calculated it above. Okay, and then now remember that anything that's +1 and -1 stays the same. So I'm going to graph or replot these points over here. Notice they're very, very tight and very, very close to the asymptote. All right, so now if you want, you can take a reciprocal of some numbers. So you can see that the reciprocal would be of 0 would be undefined, and that's why we had our asymptotes. And this we have 1/3, 1/4, 1/3, and -1/5. So these are actually very, very small numbers. So when we graph this on the grid here, they're actually very, very tiny. So at -6, we're going to have we're going to have +1/4. Okay, and then on the right side, these numbers here, that's -5, so this will be -1/5, which is very, very small here too. And that would be the same on this side as well. So when you graph these, you get a U in the middle. Oh, should get that a little bit better. So you will get a U in the middle. Try not to touch your asymptotes. And then on the right side, you get an L, but it's very sharp here like this. And you get one on either side of the asymptotes. So this is your reciprocal. So let's label this so that we know which one's which. So the red one is going to be our reciprocal, 1/f of x. And then the blue one is our original, y = f of x. All right, let's take a look at one more so that you can see how this is done again. So given f of x equals to ½ x squared plus 2x minus 7, we're going to sketch the original and then the reciprocal on the same set. And then we're going to find the asymptotes. And then for something different, we're going to find the domain and range. So the reciprocal is going to be our 1/½ x squared plus 2x minus 7. So let's find our asymptotes first. So we're going to set the denominator equal to 0. And I don't like that fraction, so I'm going to multiply everything by 2 on both sides. So I get 0 equals x squared plus 4x minus 14. I can see this is not factorable, unfortunately, so I'm going to use the quadratic formula to find x. So I get 4 squared minus 4 times 1 times -14 inside the radical, all over 2. So just simplifying the radical inside, I get plus or minus √72 over 2. So I'm just going to use my calculator and find the two values so I can find my asymptotes. So x equals 2.24, and the other one is -6.24. So these are my asymptotes. So they don't work out very nicely this time, and that's why it's important actually to draw the original graph so you can see exactly, or approximately I should say, where it crosses, where the original graph crosses the x-axis. So let's take our equation and let's graph ½ x squared plus 2x minus 7. Now to do this, actually we need to complete the square. So I'm going to have y equals, and we're going to factor out the half, okay? And let me just rewrite this. Oops. We're going to factor out the half, so I get x squared plus 4x, and this is where we complete the square. Remember, plus something, subtract something. But we're not going to take the half out of the -7, so we're going to leave that on the outside of the brackets. So to complete the square, we take the middle coefficient, which is 4, we half it, which is 2, and then we square that, which is 4. So we're going to add 4 and subtract 4. And let's kick that last term out so that we can just factor these 3 terms, the trinomials. We're going to go half times -4, which is -2, and then -7. So here we have y equals a half, and let's factor. We have x plus 2 all squared and -9. So now let's create our table to graph this parabola. So our vertex is -2 and -9. Pick two numbers on either side. And because I see that this is a fraction of a half, I'm going to skip count by 2's so that I will guarantee that my y values will be integers. So I'm going to pick -4, -6, and 0, and 2. So plugging in -4 or 0, I'm going to get -7. And then plugging in -6 or +2, I get -1. Now notice my y values are still all negative, so I'm actually going to pick one more value. I'll pick 4 to see if I get to the positive side so that I actually cross the x-axis. And when I plug in 4, I'm going to get +9. Okay, so you can pause again. I'm going to pause here so that I can graph. All right, so here I've graphed the original parabola. So now I'm going to go through the steps to graph the reciprocal. So all of our x-intercepts, so here and here, they're going to become vertical asymptotes. Okay, and then where the original graph hits 1 and -1 is going to appear again on the new reciprocal graph. Now notice this is very tight in here, okay? We're going to take the reciprocal of some values. And this time I'm not going to do it in the chart. I'm just going to do this manually here. So here I see that this is -9. So this will become -1/9. Very, very tiny, close to the x-axis. Even here, this is -7. So this will become -1/7. So still very, very tiny. So really the only point here is the one that we're really concerned with. The -1s. So we're going to connect these points here. And this is going to have a very sharp turn going towards the the asymptotes. And try not to touch the asymptotes. On the left and the right side, this 1 and the -1 is very, very close to the asymptote. So we're going to actually have very sharp turns here. So we're going to have an L over here, a backwards L on the left. And remember that if you want, you can take some reciprocals. So for example, this point here is +2, right? And this would be reciprocated to give us half. And the same thing on the other side. But because this is such a tight graph, I'm just going to draw my L like this. All right, now the last thing I want to take a look at is the domain and range, which we haven't talked about yet. So the domain, you can see, is all the real numbers, except at where the asymptotes are, okay? So x cannot be at 2.24 and -6.24 from before. Now if I want, I can actually get the exact value. So let's simplify this. So this will be -4, and then plus or minus 6√2 over 2. And then x equals -2 plus or minus 3√2. So if you want, you can actually write this as x cannot equal to -2 plus or minus 3√2 if you want the exact values. Now for our range, this is the one that is interesting that I want to talk about. We can see that y is kind of all real numbers, except it seems like it should be not equal to x. The y value can't equal 0. However, when I look, this graph on the top part is all above the x-axis. So yes, we can say that y is greater than 0. However, on the bottom half, we do have a high point right here. And remember, the reciprocal of that point at the top here was the reciprocal of -9. So actually, our y value has to be smaller or equal to -1/9. Whereas on the positive side, on the positive y side, y is greater than 0 and it will never reach 0. And this will be our domain and range.